Okay, here's a problem for us to try. So we have on the Cartesian plane, we have all these segments here. We have all this information, and basically they're asking us show that PE is 4 times NE. So PE is this over here. We have to show that this segment is this distance is 4 times NE, 4 times this distance. Okay, we have to show that. Now, what we're going to do is just what I did so far. I just wrote down here the equation of this line that's given here. PQ is this, negative 5 over 12 plus 120. So I just wrote it here. And ln is here. This is all stuff that's given. I wrote it on the problem. And they also tell us that ln is 26. ln is 26. And this is a point of intersection. Okay, so show that PE is 4 times NE. Well, the first thing you should notice is that these two lines, PQ and LN, have the same slope. Negative 5 over 12, they have the same slope. So when two lines have the same slope, you know that they are parallel. They're parallel. So these two lines are parallel. So they're parallel. I can put a little arrow here to show that this line is parallel to this line. So these little arrows show that they are parallel. Now since they are parallel, then this line QL, that's a transversal. So QL is a transversal. Now if you remember from secondary 2, when you have a transversal going through two parallel lines, there's a whole bunch of angles that are congruent. So if I look at this angle over here and this angle over here, these guys are, I put a purple one there, these guys are alternate interior angles. Since these two are parallel, these guys are going to be alternate interior angles. And these guys are vertically opposite angles. They're vertically opposite angles. So I got a blue and a purple, a blue and a purple. So now we know that. So these two angles, because they're alternate exterior, the purple one. So I can put a little purple line over here for these guys. And these guys here, Q, E, P, and L, E, N, these guys are vertically opposite. They're vertically opposite. So that's the blue angle. It's the blue angle. So what do we know? When we have two triangles and two angles are the same, and the third one's the same, so that means that these two triangles are similar because of AA. So therefore, those two triangles, PQE and an angle, triangle NLE, are similar because of AA. When two angles are the same, then the two triangles are the same. Okay? So if they're similar, it means corresponding sides are proportional. So corresponding sides are proportional. So 26 here is given. This side corresponds to PQ. So I go from this angle here, let's give it another color. Let's call that the red angle. So this one here and this one here. So if I go from the red angle to the purple angle, red angle to the purple angle, those sides are corresponding. So 26 over whatever this length is will give me the ratio of proportionality. So okay, so ratio of proportionality will be PQ over LN, because those sides are corresponding. Those are corresponding sides. So this divided by that will give me the ratio of proportionality. Now I can find PQ. I can just use the distance formula and I can find PQ. So let's find ln is 26, that's given. So the length of PQ is this formula here, the distance formula, and that's 104. That's 104. So now that we know it's 104, we know the ratio of proportionality is going to be for corresponding sides. So it's 4. The ratio of proportionality is 4. So this triangle is 4 times bigger than this triangle. So all the corresponding sides are 4 times bigger. And now we're looking for PE. So PE corresponds to, so P to E corresponds to E to N, or N to E. And they are corresponding. Therefore, the ratio should be 4. And if the ratio is 4, I just multiply both sides by any, and we get what we're looking for.